First slide here looks at the whole issue really is the fact that we have legacy networks all over the planet really into traditional LMR style. Predominantly voice-centric with some data facility and applications. The issue, of course, usually is the bandwidth here. So we have limited bandwidth on this air interface. In other words, narrowband systems. What we also tend to associate with LMR networks is the dispatcher function, or operator, if you prefer, usually referred to as the dispatcher, which is distinctly different from a more commercial cellular operation. So the distinct differences are dispatcher operation, narrow bandwidth, and then other service requirements, such as group calling and so on. If we look at the cellular world, and we're talking here about LTE and moving on to 5G, this is a heavily standardized industry here. Where the technology is heavily standardized and the network architecture is heavily standardized. And these are designed, of course, for commercial operation initially, although on here it says private network. Of course, we can use these now for private networks, this technology. But the initial impetus was a commercial grade mobile broadband technology. And there's the key word. This here is a much bigger, higher capacity pipe or channel than what has traditionally been enabled on LMR networks. The core network of 4G, 5G is, of course, all IP, including the UTRAN. And so there's distinct differences there as well, whereas this might be more associated with a circuit switch network. However, over the years, we've seen the LMR core networks develop into all IP networks as well. Now, as usual, the nice thing about standardization is there are so many standards to choose from. We see here some of the LMR systems, legacy systems that are in existence in the market and used by various user groups, user organizations all over the planet. And in this column here, we see the standards body, if there is one, associated with that technology. Tetra, we associate with ETSI, P25 with TIA, and so on. Some of these technologies are more the open standard format rather than to an official standardized body. So things like NXDN, which was originally a Kenwood and JVC joint operation, and Tetrapol, and then various analog FM technologies, all open standard, usually actually standardized or regulated by a national regulatory authority. So the issue is, the key issue here is this is broadband, this is narrowband. And the traditional users of narrowband technologies, usually we associate these with critical communications, etc. They are very interested, of course, in this broadband capability for certain services they might like to use. However, this network architecture and services wasn't originally configured to support all the other use cases and services that the LMR network users would like. However, the standard body, 3GPP, decided to dive into this area, and they have created a series of releases over the years, which have gradually expanded the capabilities of the traditional commercial LTE network to support traditional mission-critical requirements, such as group calling, press-to-talk, and so on. So the issue now is then, well, if I want to retain this technology, because I've invested in it, but would like to also use this technology, would it be feasible to allow these two networks to interwork?